What is IP? What is IPv6 and IPv4? The difference between V6 and V4, we'll talk about all of these today. Before going to IPv4 and V6, what is IP? What is Internet Protocol? So if you are aware of ISO OSI layer scheme or TCP IP, the network layer has IP, Internet Protocol. It has two versions right now, V4 and V6. So when a user wants to send the data, packets from one machine or one computing device to another one, what will be the route and what will be the addressing scheme to the packets? That is, this Internet Protocol is nothing but the set of rules or guidelines so that the data can travel from one network to another. So IP stands for Internet Protocol. Each device or any device which is employing the Internet Protocol for communication, it uses an IP address for communication. That is, this Internet Protocol is one of the protocol in the stack, layer stack, and that defines how to communicate, and that comes down to the IP address. So here you see a picture of the machine, a computer, where you are actually seeing the IP address. These are just numbers. So I'm just opening my laptop, these settings, and then you will see what do you see, where do you see, how can you change. So this is how I'm moving to that space. Right now I'm connected to internet. So this is how the network setting or network adapter setting you can change or you can see. So here you see the IPv4 and here we have IPv6. Let me open this. So this is the TCP IPv4 and the number can be automatically generated DHCP or you have to manually configure it. But IPv6, it's just automatic. So this is how the IPv4 and IPv6 you will find in your system or computer. Let's come back to our discussion. IP address you have just seen. What was that? It was just a numeric number, numeric address. So this is a numeric address identifier. Why it is called identifier? Because it can identify the device on a network. It can be a small network, it can be a company network, or even it can be an internet. Right? So this IP address is actually the base of IP. Why? Because IP address specifies the technical format of the addressing and packet scheme which you see here. So we were talking about Internet Protocol, the set of guidelines or rules for routing and addressing packets. This is how it is done. The number which you see is actually the addressing scheme. So IP address consists of two parts. We are talking about IPv4 right now. So from here to here, the first 3 octet, this is called the network address, and the last one is actual your computer address, which is called the host address. That is, packet when you send, it will go through all the networks and finally it will go to the host. So which network it will go is decided by network address and finally your system, which is your host address. We have already discussed there are two types of IP addresses. IP version 4, IP version 6. IP stands for Internet Protocol only. So this is how the numbers, or you can say alpha numeric numbers, will be seen. IP protocol has, in order to implement it, you will have an IP address. This is a number. So this number is employed or used to identify, let me add, uniquely identify a computer or a computing device in a network. He is, I don't have to give any introduction. Everyone knows him all over the world, you know. So he has an address. Okay. Now this address, when you want to meet him or you want to send some appreciation letter or love, what you'll do? This is the address you are going to send. So you can take an analogy how we can compare an IP address to a street address in the area. If you want to go to a particular person, meet him, you need street address. But if you want a particular computer, the data to be delivered, you need an IP address. So with this address, like this Tom Cruise address, one can deliver a letter, go to the location, meet him. This is what is done by the IP address. So every computer in a network has an address, same way Tom Cruise is having this address. Now here are two Tom Cruises. How are we going to identify which to send? The two computers, same face, same name, same address. Is it possible or not? We'll see just now. We'll talk about IPv4 and IPv6. IPv4, Internet Protocol version 4. Before we go ahead, the introduction also, before that you need to know how it looks. These are 1, 2, 3, 4 numbers, and they are separated by dot or period. We call them as 4 octets. So this IPv4 is the Internet Protocol version 4. This is a IP version, and this is widely employed, used to identify devices on a network. And this 4 octet scene you are just witnessing, this is the addressing system. This is the addressing system or scheme. Every computer will have this address. Okay? How do you give the address? Your address. You know, the number of your house, then your street or lane address, then your city, and then country, and then the PIN number. Similarly, for a computer, this is the address. So this IPv4, it was the first version of IP, and this was deployed for production in the ARPANET in 1983. You know about ARPANET. If you know about internet, you know about ARPANET. So 1983, most of the people, we were not born at that time. So this is a 32-bit address. 1 octet is 8-bit. That is why we call it as octet. Oct means 8. So 8-bit, we have how many bits? 8, 8, 8, 8, 8 4s are 32. So we have 32-bit address. This is the whole scheme. So how many addresses it can generate? 2 raised to the power 32. So 2 raised to the power 32, the number of addresses will be around 4.29 billion addresses. Assume in 1983 people might have thought 4.29 is a very, very huge number. But we'll talk about IPv6, why it come. So it is considered to be a primary internet protocol, and almost, a very huge area it covers, around 94% traffic. So it is a 32-bit address, and they are separated by, these are called as field or set. They are separated by dot or period. Period means dot. And please remember, this address is unique for each device, especially when you are connected to internet. It will be a unique address. So these two which are nearby also, they will have entirely different address. Means a unique address. IP version 4, Internet Protocol version 4, this is just an address, just a numbering scheme, just a routing way. So this IPv4, as I said, there are 4 groups or set. 1, 2, 3, 4. 4 group, set or field. And as I said, that you can call them as group, set or field. In various books you will find various terminology. Now since we have 8-bit, this 192 is just a decimal number. But computer knows only bits. So it is 8-bit. How many octets are there? 1, 2, 3, 4. 4 octets are there. So every group 8-bit, in all 4 groups, so it will be 32-bit. And there are 3 dots. Please remember 3 dots because you are separating 4 decimal numbers. So this is called as decimal dotted scheme. The bits in each octet is representing a decimal number. When you go to the computer will not know this. It will have to convert the 192 into bit form, 01 form. Every number, as I'm saying, that it is 8-bit. So 0 to the power 2 to the power 8 minus 1. As we are starting from 0. So the number can be minimum 0, it can be maximum 255. That is, every number, 4 numbers you are witnessing, it can only go from 0 till 255. So this can address how many addresses? That is, 32. So 2 to the power 32. 4.29 billion around. These are the possible unique addresses. But in computer network or computer world, computer don't understand this IP. This is the numbering scheme we have developed. So this is a standard numeric format. It doesn't understand. Computer has to convert 192 2 bits. 149 2 bits, either 0 or 1 form. 252 76 201 form. That is, this decimal will be converted to binary. So this is the IPv4 address format, also called as dotted decimal notation. There are 3 dots, there are 4 numbers. These 4 numbers can go from 0 to 255. And every, especially on internet, this will be a unique number. So every number will be converted into binary. This is the binary equivalent I have shown. I hope you have a fair idea about converting decimal to binary. And this one binary is actually 8 bits, which corresponds to 1 byte. 1 byte is 8 bits. So how many bytes are there? 4 bytes. So how many bits are there? 4 into 8. So that is how 4 bytes will make 32 bits. So IPv4 is all about this. If you understood all this, you have understood IPv4. So we have 4 octets, decimal in between. The numbers are from 0 to 255, minimum 0, maximum 255. IPv4 also comes with a class. That is, we have IPv4 classes. For example, class A goes from 1 to 126. These are the first octet I'm talking about. Class B 128, 191, class C is 192 to 223, class D is 224 to 239, class E is from 240 to 255. Okay. There are default masks also. Mask is just to, separate out certain numbers and just filter out certain numbers. So loopback is 127, class D and class E are reserved for multicasting, and experimental loopback is simply, sending the message and receiving it back. This IPv4, it uses 32-bit address scheme. It can store 2 to the power 32 address. That is, it can address up to 4.29 billion addresses. That is 4.29 billion devices. But what is the population of world right now? It's 8 billion. 8 billion. 1.4, 1.5. It's around, the Indian population, China equivalent. This will cover only 4.29 billion because everyone is having a laptop, a palm top, a watch, a mobile and whatnot. There are so many gadgets. So this 4.29, if you take one individual, we are 8 billion individual. Are these addresses are going to suffice? No. What is the solution? The solution is we have to develop a new addressing system or scheme. IPv6 is the new addressing system or a scheme, and it is not 32-bit, it is 128-bit, so that it can address 2 to the power 128 devices. Okay, so this is how IPv6 has come into advent, has developed. IPv6 or Internet Protocol version 6. The previous version was v4, this one is v6. If you go to your computer, you will see in TCP IP, this is this kind of number you will give. For the first time, it may seem complicated because it is all hexadecimal. The IPv4 was all numeric. So IPv6 address example is like this. This is a very simple example I have taken. So IPv6 or Internet Protocol version 6. This was deployed, this was, started in discussion when we had the high demand for IP addresses, because IPv4 only 32-bit address, so it can only cater up to 4.29 billion addresses. We are 8 billion people. Every person is having 2-3 gadgets now. So this is the most recent generation of Internet Protocol IP. It was introduced in 1998. in different articles or website, you will see 1995 also, 2017 is the latest one. Basically, when it was actually agreed on IETF, I'll just show you, that was 1998. So this was defined, this is defined in RFC 2460, defined by the IETF, Internet Engineering Task Force, and that is how we have got this 1998 number or the year. So IPv6, it is not only solving the problem of limited network addresses resources, because the problem with IPv4 was that. But this IPv6 is also resolving the barriers for multiple access devices to connect to the internet. IPv6 address, which you see here. First of all, it is a 128-bit hexadecimal number. Two things you have to remember. 128-bit hexadecimal number. IPv4 was what? Totally numeric. 1 octet, that is from 0 to 255, one group or field can go value. IPv4 was decimal. That is why it was called as decimal dotted notation. But here you have 0 to 9 and A to F is also included. So all in all, you have 16 of them, 0 to F. F correspond to 15. So we have hexadecimal address being used, and since we have colon in between, IPv6 is a 128-bit IP address. Previously, IPv4 was 32-bit addressing scheme. So 2 to the power 32 you can address. Here you can address, or you can give the address individually to all the system in the world. 128, 2 to the power 128, and that number is huge. Now new terminology was invented, 340 undecillion. So 3.403 into 10 to the power 38. Not only you take the Andromeda galaxy, you take all the, whole solar system, and you have people there. You can assign the number, addresses to their machine. Alright. Please recall, IPv4 was 32-bit address. It can only cater to 2 to the power 32-bit, that is 4.29 billion addresses. But IPv6, 340 undecillion. So we have here 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 sets, 8 field or 8 groups. How are they separated? They are separated by a colon. That is 2 dots vertically. This is the colon. So these are separated by a colon. Each set, field or group, these are 16-bit. 16, how many are there? 8. 16 into 8 is what? 6 8s are 48, 8 4 carries, 8 1s are 8, 8 1s are 8, 12. 128-bit has come from there. Hexadecimal I already told you, and each hexadecimal character is representing 4 bits. For example, O, D, B, 8. This 0 or O, it will not be O, it will always be 0. We just have from A to F. So every D, B, 8, all these are 4 bits. So that is why we have 4 of them, and 1 is 4 bits, so 4 4s are 16. So one group or one field or one set is 16-bit. Each hexadecimal 4-bit. This hexadecimal address, it contains not only the numbers, unlike the IPv4, it has alphabets also. A to F we are employing. Now, what is the meaning of different sections of IPv6? Because it seems complicated at first sight, but it's not if you understand each part. So we'll take the same example. This is a very simple example. 16-bit I showed you, 128 bits how it has come. So one of these, which is the one of the first part. The 2 is the global unicast address indicator. What it is referring? It is referring to sending message to a single network destination which is identified by a unique address, which is this whole address. So the first number, or you can say the first in that field or group, the first hexadecimal value is corresponding to the global unicast address indicator. The second one, which is complete 001 here, I am taking the first one only, first group. 001, This is corresponding to a region. It can be Africa, it can be Latin America, like that. We have 0dB8 here, and this in this example is called the Local Internet Registry, or LIR, or also you can just say that it is the identification of the Internet Service Provider, ISP. The AC10, this is for you, who is the customer. So AC, there is a service provider, there will be a customer also, AC10, that is corresponding to it. Then we have FE01, this is a subnet. So there are different networks, the networks have their subnetwork that are called as subnets. Okay, subnetwork. So that is the number, FE01. And after that we have 4 more of these numbers, which are, or the hexadecimal numbers separated by column. This whole is a 64-bit extended unique identifier, EUI64. Okay, extended unique identifier, and this is specially for your computer, your system. So this unique EUI64, which is a 64-bit IP version 6 interface identifier, this is assigned directly to the host, that is your computer, without any manual configuration or even DHCP. You don't have to do DHCP or manual configuration. It is assigned like that. So this is the final part, which is called as EUI64. That is how you can remember. IPv4 and IPv6. IP Internet Protocol version 4, IP Internet Protocol version 6. The first thing is, IPv4 was the first popular addressing scheme. Then came the IPv6. In a whole galaxy, if you want to uniquely identify a computer, say on internet, how are you going to identify? This is by this address. These are just addressing scheme, nothing else. And they are implementing the IP, Internet Protocol, of the network layer of the layer stack, or ISO-OSI and TCP/IP. Alright? So IP protocol is implemented by this addressing scheme, used for uniquely identifying your computer on a huge internet. So IPv4 came 1983, IPv6 1998. You will also see it 1995 and 2017, because different IETF and etc. have given its go ahead. So when you want to go to somebody's house, you need an address. If you want to send a data to another computer, you need an address. So the IPv4, if is being used, it is 32-bit addressing number scheme. The IPv6 is 128 number. IPv4 is the address format is dotted decimal notation. You see 4 different numbers from 0 to 255 separated by a dot or a period. The address format, on the other hand, for IPv6 is hexadecimal notation. The IPv4 will have only number, numeric. The address format of hexadecimal notation for IPv6, it will contain numbers also with the alphabets. So how much is this? This is 8, this is 8, this is 8, 8-bit. So 32-bit it is. That is how 32-bit has came. This whole every part is 16. There are 8 groups or 8 set or field. So 8 into 16 is going to be 128. That is how 128 has come. And every, that is F, is 4-bit. That is how 16 has come. How are they separated? They are separated by colon. This double colon is just a way to shorten this address, because it is a big address. But the main thing is, it is a 128-bit alphanumeric address. And here IPv4 only numeric. You don't see any alphabets there. In IPv6, you see the address properly. You will see the numbers and alphabets also, alphanumeric. So the bits in IPv6 are divided by periods or dot, or you can say the groups or octets are divided by period. The IPv6, the bits are divided by colon. The difference between IPv4 and IPv6, as we have seen, the IPv4 is 32-bit addressing scheme. So how many addresses it can generate? 2 to the power 32, around 4.29 billion. How many people are there right now on this earth? 8 billion. Will all be able to get the address? No. No. You know, India and China, if you combine, it's more than 3 billion. So 4.9 billion, in order to cater this, what do? Everyone has a tablet and a computer or a laptop. So how to cater to this 8 billion people and maybe more going ahead? So 2 to the power 128, because this IPv6 is 128-bit addressing scheme, you can generate 2 to the power 128, that is 340 undecillion numbers. So let me tell you again, IPv4 maximum 4.29 billion unique addresses it can generate, but IPv6 3.4 into 10 to the power 38 unique IP addresses can be generated. If you are going to the header scheme or the functionalities, you will see that IPv6 it already implements an IP security IPsec protocol. IPv4, if you are using IPv4, the security is dependent on your application you are developing. If you see the header very closely, IPv4 has checksum fields. Checksum means if some error is there or not in the bits when it is received at the destination. IPv6 does not have any checksum field. That is, you are sending certain bits, whether these bits are received properly or not, that is checksum. In IPv4, the networks are configured manually. You give the IP addresses manually, or it can be given by your network administrator by DHCP, Dynamic Host Configuration Protocol. Alright, if you are making your own network, you can give your manually or DHCP. In IPv6, networks are automatically configured. No manual thing here. Again, going back to the header, IPv4 has 14 header fields. Length is 8 characters. Please see to the left of IPv4 header. 14 header fields, 8 characters. On the right, IPv6, 8 header fields, length 40 characters. IPv4, it operates with Address Resolution Protocol, ARP we call it as. IPv6, the same work, it uses NDP, Neighbor Discovery Protocol, for mapping MAC addresses. Every system has a network card, an IC card, and it has a very unique MAC addresses. So there is that correspondence. IPv4 it uses ARP, it uses NDP. So I hope you got a very fair idea about IPv6 and IPv4. Thank you so much. Take care of yourself.